Okay, in this problem we're asked to find the area of the region bounded by y equals 5 over 3 and y equals 1 over the square root of 9 minus x squared. I went ahead and drew the graph here. So this parabolic looking shape here is the 1 over the square root of 9 minus x squared, and of course we have our line here. So we're looking at our region in between these two. Okay, so the first thing that we want to do is find the intersection points. That will give us our limits of integration. So we need to set these two things equal to one another. So we have, let's see, 5 over 3 is equal to 1 over the square root of 9 minus x squared. The first thing I want to do is just take the reciprocal of both sides of this, just flip them both. So we would get, let's move on over here. We would get 3 over 5 equals the square root of 9 minus x squared. It would be over 1, but we don't need to put the over 1. So we square both sides. We get 9 over 25 is equal to 9 minus x squared. Okay, move the 9 over, and then take the square root of both sides. So you end up getting x is equal to plus or minus the square root of 216 over 25. And you can take the square root of the denominator if you want, or you can just leave it like that. I will go ahead and do it. So square root of 216 over 5. Okay, plus or minus. So those are our limits of integration. When you're bounded by a curve, you do top minus bottom. So if you can look at the graph and you see which is the top and the bottom function here. So the top is going to be 5 over 3. The bottom is going to be 1 over the square root of 9 minus x squared. So we get the integral. Here's what I'm going to do to make this a little easier when we plug in our limits. You can see that we have symmetry here. In other words, the left side of this and the right side of this are the same. So if we just take the area of this to the right of the y-axis here and then multiply by 2, that'll make it where we can plug in our lower limit of 0. It should make things a little easier down the road. So I'm going to go 2 times the integral from 0 to square root of 216 over 5. If I didn't do the 2 times, in other words, if I didn't use the symmetry, my bottom limit there would have to be negative square root of 216 over 5. Okay, but using symmetry, stick a 2 out front, it's going to make it easier to plug in our limits when we get to that point. Okay, so top minus bottom, 5 over 3 minus 1 over the square root of 9 minus x squared. Okay, we'll do this term by term. It's dx. We'll do this term by term. So the 5 over 3, when we integrate that, just becomes 5 over 3 times x. And this term right here, the 1 over the square root of 9 minus x squared, that becomes arc sine or inverse sine of x over a. What is our a? Well, if this term is a squared, then a squared equals 9, then a is equal to 3. Okay, let me write that down real quick. So the integral of 1 over the square root of a squared minus x squared dx is equal to, running out of room here, is equal to sine inverse of x over a plus c. Now we're not going to use the plus c because we have limits of integration, but this is what this becomes. So you can see that the 9 is where the a squared is, and the x squared, of course, is there. So it becomes x over 3 for our case. So let's go ahead and integrate. So we have 2 out front. We already said that this becomes 5 over 3x. And then this becomes minus. The minus is because there's already a minus there. Minus sine inverse of x over 3. And that's going to be integrated from 0 to 216, square root of 216 over 5. Now you can see why our limits of integration is easier, because if you look at the 0, when we plug in a 0 here, 5 over 3 times 0, 0, that's gone. When you plug in a 0 here, this becomes sine inverse of 0. So if you think about that, sine inverse of 0 is the question, where is sine equal to 0? Okay, and it's equal to 0 at 0. So you get 0 for both of these. So the lower limit, when you plug it in, it just goes away. So we'll only have to plug in the upper limit here. So 2 out front, 5 over 3 times the square root of 216 over 5 minus sine inverse of square root of 216 over 5, and there's already an over 3 there, so over 5 times 3. Okay, so both of these are going to have the denominator of 15. Okay, so this one, of course, we can just cancel that out. So we get 2 times the square root of 216 over 3 minus sine inverse of the square root of 216 over 15. Okay, now if you want a more specific answer than that, you'll have to go to your calculator. So let's go ahead and go to our calculator and do that. Okay, so we get the 2 times the square root of 216 divided by 3 minus sine inverse of the square root of 216 divided by 15. Okay, that doesn't seem quite right. Let's make sure I did that right. Oh yeah, I didn't multiply by the 2 here. So I made a slight mistake. Let's go back up here. When I was distributing the 2, I did it to the first term, but I forgot to put the 2 on the second term. So let's put a 2 right there. Sorry for that mistake. We can just hit second enter, and we can go in here and we can put a 2 there in front. Okay, that seems right. I know that because I did the problem earlier. All right, so 7.059 is going to be our answer.